Hey guys, welcome back to the channel. I have two Marine ECMs coming from Washington State. Andy, Bokor, these are your computers. I'm going to show some of the pictures of how these came here because one of the computers was open and really damaged inside. That I have to correct that in order to make it run. So not sure if that was the damage that he had, because it's definitely self-inflicted, because now the computer is running good. So, but yeah, so let me move you over to the next capture I normally do. You can see the computer running. I have one connected, and this is it's a MEPI4B. The part number for this family is 12584052. The last digits on the sticker, they are very unique to each computer. In this case, is letter A 61350064. That is for this computer. Not sure what this is set to, because I don't think he put any information in there. Let me just read that and or show you. Well, let me move you over to the screen. So this is before I even connected. I see the one on the right side, and where we're working. I have connected now, as you can see right here. Letter A 61350064. Those are the numbers that I was reading, and this is the family numbers that I refer to. This is a specific for MEPI4B. You can see the duct tape on the sides, and that's it. As far as information, I have no emails from him, and I have checked everything. Let me just do one check. Well, when I do that outside the camera, just to check if it's in bookings, because I always request people, please send me an email like that. I can understand what your concerns are. This is all I got from him. So again, it's Andy Bokor from Bellingham, Washington State. It says one, which we don't know which one, because they're not marked as far as the problems. I am the one that put that Andy Bokor, Washington number 1 and number 2, because I want to separate that for a video. But yes, you can see they're both the same part number, and they're both 5.7. I haven't run the other one yet. And it says only fires. One says only fires for injectors, and the other one says no start. Hard to know which one is the one with the problem. Again, it's not marked. At least I don't see that. So let me take you back to here. In the meantime, I'm just going to go over to my website 1 second to check the bookings, just to see if by any chance he was probably set up as a booking and I don't have it here. I am going back in time. Marine ECM. Boys 50. Let me see what is his email. No, his email is Andy M. Bokor. So this is not Marine ECM. That's somebody else. That's John from Florida. Then we have down in here. That is, I'm going back to September 14. This computer got here September 29th. So I will say maybe 10 days on shipping before. But yeah, I'm going back to like September 10, and I have no bookings from this person. So I am absolutely lost on who this might be, because like I said, I have checked all my emails and everywhere. And this is where sometimes it gets a little hard. People don't understand there is so many different sources that, sometimes it's hard to find your information. Please text me, email me. I'm going to even check my phone just to see if I have any messages from him. Let me check for that specific number. Actually, 1 second. Yep, no, I have nothing, not even on that number. So, yep, a little hard to know exactly what we got. But yeah, so let me put in here the picoscope, the diacom, and one of the pits that I selected just for the RPMs. So the signals you see on the bottom of the screen is the oscilloscope, which is a graphing, let's say it's not a graphing multimeter, but just so you understand better what that is. The oscilloscope is a fast capture tool that will graph the signals, voltages, right, as they change through the circuitry of these tools, right? And it has a software, Pico, really nice because you connect this to any USB port or and that transfers over to this software, and it has a lot of measurements that I can add. Like in here, let me just show you. I'm going to add 2 measurements in here. Give me 1 second. I'm going to add a maximum in channel A, and then another maximum in channel B. A is blue, B is red, and we can see the maximum is battery voltage. I can also add a minimum in channel A, and then another minimum in channel B. So now I'm going to move the bottom of the screen up so we can see all. Yeah, you can see very well from there. But everything is looking pretty normal, right? So the injection is completely normal. It's firing all, and both injector drivers are pulling down to ground perfectly. So there is no issues on that. I'm going to move one of the channels over to the coil or ESC driver, right? And we can see now in the red channel how the coil signal, because it's for A coils, is more of those signals being pulled, right? So that's the coil through my driver. I can also, if you can see there, I'm going to move you over to codes, and we have no fault code. So this computer is running with no codes at 650 RPMs. I also forgot to mention, from now on, I'm going to be using a relay to command the fuel pump. So I'm connected everything as is in the vehicle or in the boat. So there is no misunderstanding if the load for the fuel pump, because I have a customer that said that his fuel pump relay failed later, or I tested and it failed, and it's because I use a load like a test light. So I'm going to be using that as from now on for all the computers, because I said, yeah, sometimes it's hard to reproduce your concerns. I had never seen one fail, but he said so. He said that he sent this to somebody else and they fixed it. So, and all I got from these tests, so it was 2 years ago, actually. So, yeah, you see what I mean? So 2 years later, he said, "Oh yeah, finally, I need to tell you that your test was wrong and the computer was a problem." And I'm like, "Yeah, well, okay." I tested the computer, and all I got it was a test fee. I'm sorry, I cannot reproduce your concerns in here. That's it. I tried my best, run it for more than 1 hour, loaded with real injectors and everything, and I couldn't ever make it react. It was never very concise of what this problem was. 2 years later, he said, "Oh yeah, the relays were flickering." I'm like, "Well, yeah, in your notes, that was never there. If you watch the video, you know who I'm talking to." But yeah, those are limitations, and this is where I always try to stress the technicians or the boat owners. I need specifics. If you think that you're going to send a computer and I'm going to give you a clean bill telling you, "Oh yeah, this is perfect," you look into, no, I never do. I never do. I said, as far as here, your computer is running normal here. What is in the boat or what you have in the boat, I don't know. And the loads can be different. There's temperatures, vibrations that I cannot reproduce, and it's impossible. So without your guide and narrowing down what your problem is, if you just send a computer, I have let's say, a rich condition. Yeah, that's going to be almost impossible for anyone to reproduce and to try to correct, unless it's something very specific, like, like an ejector shorted or something like that. But that's when, if I have a more guided fault or concern, like injectors not running or no start, no communication, well, that is definitely, you cannot run the boat. But yeah, symptoms don't work for any facility. You need a specific problem. So let's say you got a rich condition. The next step that you or your technique needs to do is, okay, are the injectors staying open for too long? What is the injection millisecond running at idle? It's like, let's say, the computer is commanding, and this is where diagnostics and an oscilloscope in the back end can help you. Because let's say right now we have the injection millisecond. I'm going to deselect this one, and I'm going to select the injection. Yeah, you can see 2 milliseconds. If I go over to the oscilloscope and I add another measurement, I can go into the low pulse width. And now you can see the low pulse width at the bottom. The last one is 2.6, 2.8 milliseconds. Very close to what the computer is doing. A little off, but that is nothing that will create any issues. Why? Because it's a clean injection. Everything, this computer has only 2 drivers. So each of those drivers will fire 4 injectors at the same time. So in order to have 4 injectors not firing, it will have to be one of these drivers shorted or not firing at all, right? So that's not the case here. So, but yeah, so if you have a problem in your boat and you tell me, well, yeah, Mike, the computer is commanded 2 milliseconds, or at idle with everything normal is commanded 20 milliseconds. Okay, well, that's very abnormal. That could not be correct. And then, oh yes, well, that will definitely create a rich condition. What is your manifold air pressure sensor reading? Normally, at boat reading idle is in between 12.8 to 13 inches of mercury. And that's what I usually put it here. Again, let me deselect this bit. And I'm going to show you how I'm using 12.8, 12.7 inches of mercury as a manifold air pressure. And that converts into voltage, because you can also see that in these computers, of 1.76 volt DC. Sometimes when the calibration get damaged and it gives no faults, you might have 1.7 volts in the as voltage, and the computer is now thinking that that is 20.7 inches of mercury. So if you have 20.7 inches of mercury, let me just do that. I'm going to change that because this is a very nice and controlled environment, right? So I can do whatever I want with the computer. I'm going to change the manifold pressure to 20. Let's do 22 to not go too crazy, right? All right, so we got 22.7. Well, guess what the fuel injection is now? You can see it also on the scanner. It's 5 milliseconds, 5.8 milliseconds. So that will be double your injection time. So the injector is now staying longer open. Why? Because the computer thinks that your manifold air pressure is 22.7. At idle, that is impossible. It's no right. So you go in, if you have a problem like this, what you need to do is use a multimeter, or better if you use an oscilloscope, but if you use a multimeter and read the voltage, and the voltage is at 3.1, well, that is the correct pressure. So something is adding pressure in the manifold. We need to check valves. We need to check leaks. We need to check something. Something is definitely changing. But if you go there and your voltage, I'm going to drop it down to the normal reading. It's 1.76, 1.77, and it's reading 30 inch or 22 inches of mercury. Well, that calibration is corrupted. Even though it has no checksum errors or so, is wrong. Why? Because the voltage is correct, 1.7, 1.8 volts, but it's thinking it has the double amount of inches of mercury. So that is a bad calibration, and it has to be rewrite. You see what I mean? So with those values, with that information, a full recording of your running problems, I can help you. But a symptom, very, very hard to reproduce, very, very hard to help you. Think about it. You cannot fix a symptom in your boat with everything connected. And I mean, if you have problems and your mechanic does not have a diagnostics, I always recommend everybody, you know what, go and get Diacom. Bring that Diacom laptop or Windows base. Is if you buy it specifically, let's say for Volvo Penta, it's less than $700. That's very affordable. I mean, you're going to spend a lot more money on parts working blindly than getting the tool and then a technician or a person like me, because I also offer the service to go online with you with manuals and everything with TeamViewer and walk you through diagnostics for obviously for a fee and then correct situations. But I need to have something I can connect and see, because a camera, yes, you see how better it's running. Yeah, that's not how it works, right? So I'm just trying to put this out here so I can help anyone that is watching the video and make you understand what is necessary in order to diagnose properly a vehicle, boat, car, jet, airplane, motorcycle, anything, right? So this is very important. All right, let's go back to our test. So I'm going to reselect the RPMs because I want to see what happened with this computer gets into higher RPMs, right? So we got the fuel pump relay in there. We got everything that we need. So let me increase the RPMs. We're in 1,000. Try to go over 2,500 RPMs. So we're in 3,000. I need to increase the throttle. You're not going to be seeing that right now. We're in 8.6. I'm going to put that around 25 or so. And I'm going to increase the manifold air pressure, right? Because we're now at 3,000 RPM. So do that 1 second. I'm going to put it just around 19 just to increase something. You see if something changes. Yes, we are in 19 inches of mercury. We are in 2.6 volts on the manifold air pressure, and our injection in the computer is showing 4.9 milliseconds. The reality on the scanner is 5.6. So we got like a 0.8 milliseconds of difference of what the computer is supposedly doing and what is realistically happening, and that is very accurate. The oscilloscope is the reality. The thing with the computer is it's already process data into the scanner, right? So that's what we're seeing, process data. So you can take that with like a little bit grain of salt. It is very close. Voltages should stay really, really accurate because it's an easy signal, but you know, there could be a little discrepancy here and there. Take that, you know, with like knowledge and experience through the years. I know that that is not a problem. But yeah, so I have IAC movement, I have sensor ground, I have 5-volt reference, and it's actually even running good at 3,000 RPMs. I don't see absolutely nothing wrong with this computer. I also want to show you now that on this entire time this computer is being connected in here, or the whole time this computer is being connected and running, we have almost 40 minutes. So yes, my diagnostic fee is not just because I connected and I said, yeah, is this a good computer? Is this a bad computer? No, I run it. I go into the board, I check, and I fix. So I don't know if I show you. I always go with it, you know, with the talking and everything. So let me bring this down 1 second because I'm not sure if I did show you that. But going into his pictures, because I think I say with the conversation here, he opened this computer, and this is what I have. So like I said, I'm not sure if this was the damage on this computer because you can definitely see that this is definitely a self-inflicted problem. All these jumpers in here is the cable that connect each of those wires from the sensors and powers and grounds from the connector to the board, right? So if those are shorted inside, of course, it's not going to work. But I would not suspect that he took this and damaged it and then plug it in. Oh, I now have a problem. He was trying to correct something. But I always tell everybody, please, please don't open computers. This is a damage. The word jumpers is completely ripped out of this connector on this side. A little hard to say on this computer. I mean, to see on this picture, but you know, it's because of the yellow that it's hard for the camera to really pick up. But it was actually 3 jumpers completely ripped out. So I have to fix that. And is that going to be included on the test fee? Of course not. That's a repair. So you are self-inflicting problems that is what the problem was in the boat. I'm not sure because I'm not even sure which computer is this one. So, but yes, I have to correct it and I have to fix it. So this is going to be a repair fee for this computer, and I want to show that to Andy because of obvious reasons. So this is definitely not a normal repair, not a normal board that came here fully working or not or never open. This is a completely different animal. That's how I like to describe it. Let me put the RPMs again. All right, so I'm going to come down to idle. All right, we're in 640 something, so I have to bring the throttle to around, I keep it in between 6 to 10%. And let me bring the manifold pressure to 12.8, 12.7 as I normally do. All right, that's perfect right there. And we see injection, we see fuel pump is staying on. We are not missing anything on this computer. So Andy, yeah, this computer is fixed. What was the problem? I'm not really sure. Not even know what boat are we working or anything. All I know these are 5.7 computers, 5.7 liters, MEFI 4B, and this one it has 470.6 hours. I saved the first hours of everything in here. So you can see in there it has 470.6 hours. The calibration section for this is C4D4. I was looking into my information. I couldn't find it, so I'm not sure exactly what we're working on. I might probably contact them and see, just to put them in my file to see what this calibration was for. It's running good. I don't see any problems in here, so I'm calling this one a fix. All right, guys, so let me stop 1 second because I want to connect the other computer. So actually, let's do it on the video, right? So let me accept this one. So I'm going to tap the RPM and then turn this off. You see, we're losing communication, obviously, because I turn them off. I'm going to power this off 1 second because I like to have no power when I'm unplugging and plugging a computer here. I'm going to put the cover here so we can see this computer, or he can see his computer here. And we're going to try to see what is wrong with the other one. 1 second. All right, so this other one, the part number, which I already have saved on at least on the folder, I have nothing because I'm not connected, is letter 870590103, and it's the same family, 12584052, some FE4B as well. And hopefully you can see the letters. He will, not sure what it says, 350 BFI or BF1. I mean, yeah, 350 is a 5.7, but not sure what this is for. All right, so that is now there. So let me power everything back on. And the reason I do that is because I have these boxes always powered up. So let's turn the ignition and see if we have fuel pump. And we do, right? So we do have fuel pump. That's a good thing. We have, it's a little far away for you guys, but we do have sensor ground and 5 volts. That's a good signal, or a good sign. So let's try to connect. I'm going to establish the communication from scratch. So we're going to select MEFI 1 to 4. All right, it is definitely reading. And we're going to connect. This is a completely different calibration. All right, so, and this is exactly what I like to do. You know, this is calibration 23B3. It has four full codes, but and it has 436.8 hours. Let me write this down to put them into the folder that I'm going to create for him and everything. So we have, and it is a 5.7. Yes, it is. So 5.7 cal. It's a 23B3. And it has 436.8 hours. All right, so I think I showed you already that. Let's see what fault codes we have. All right, so we got injector A and injector B open, high and low. All right, so it has 81 code. This is what I'm talking about, collecting data. This is not about just, yeah, I like and I need all this data. If you're going to send me a computer blindly to think that it's repairable, well, it might, but it might not. Especially if I cannot reproduce your concern. In this case, I will say that the computer that we have before us, either the one with 40, well, it's hard to say now. So let's see how this one runs, if it runs. So we have injector A and B, because both fault codes are for both. Low, high, and low open. So high, and then low open, which is contradictory, right? It's either high or it's open. So because low is open and high is not open, it's shorted or so, right? So something is definitely not adding up in here. Let me get something I have in this thing. And I don't like because I can short things. Give me 1 second, guys. All right, so I gathered the information. Let's come back to the computer. So we got fuel pump, and we got find board reference sensor ground. Let's see if it is runs. So it's a 5.7. It should. So let's inject the signal. All right, we can see one injector definitely not running right. So this is definitely the injector problem. The one with 4 injectors not running. You see, this is immediately I can immediately see. I'm going to put a trigger into B channel, automatic into channel B. Just need to raise it a little bit, but we can see it in there. So I'm going to increase the time base. Well, actually, we're running in very low idle because right now, since I just run this, we're probably in 152 RPMs. So let me put the view so you can see that. And I'm going to keep it in now for that. This is like cranking mode. It doesn't matter, right? But we do have a problem already here. So I need to snap a picture of that. Here, give me 1 second, guys. Again, I am collecting the data that I need for the customer and for myself. So I'm going to take a full screen capture for him and for me when I'm reproducing his concerns. I got to do it again. Okay, I have it. Let me save it on his folder right here. Running. And this is module 2 because I already marked it, and I will record a part later. Sort it. Well, partially, right? Because that's partially shorted injector bank. And I think that's bank A because it's in the red channel. Well, hard to say. I think it is bank A. But it doesn't matter for me as long as I save that data. All right, so let's see if by increasing the RPM does any changes. So let's go over to normal idle, which is 650. All right, 650 RPMs, and we still have the same issue, right? So we can definitely see we have now more firings of each bank of injectors, but we can definitely see the driver field almost not pull. And I can definitely see here, I'm not sure how noticeable is for you guys, but this light is definitely flickering brightly, and that one is very dim. That's exactly what will happen in this injector. That will not fire. Why? Because that injector driver is barely pulling to ground. So sometimes it's not even, So if we go over to the oscilloscope and I reduce the speed because I'm now in 50 milliseconds per division, we can see that. So realistically, that injector, and it's said to be pulled to ground, which is, like the blue channel is that one is barely pulling it to 10.4, even though the minimum into our reading shows 21 or 20 millivolts. Why? Is because that spike, that reading is so accurate that it's picking that spike in there and it's saying, okay, well, we'll have a low part or a minimum part, even though it's for a microsecond, right? Because if I open directly in there, let's do a sum for just that firing. Let me move this 1 second, guys. And I move my cursors like right now we have the injection milliseconds of 3.2, and if we see in the capture, the computer is looking for 2.3. So the reality in the oscilloscope, that total amount of time is around 3.16. So that's exactly what we're reading on the blue low pulse width. But that activation that is there for a period of time, that is, I'm going to tell you how long that is. That's 55 microseconds. So that is like nothing. that's not enough for an injector to even try to open. And 10 volts definitely will never open. Why? Because the injector solenoid is meant to be open a full ground, not half, not a third. It's not partially open. It will not open, especially with the fuel pressure behind it, right? Because we had, 40, 50, 60 pounds, what depends on the setup, behind in the rail, trying to, or waiting for that injector to open to create a spray through the nozzle, right? But yeah, so 50 pounds of pressure and not even pulling to the ground, this driver will definitely not run, will not open. So this is definitely, I will consider now, based on what we're seeing, that this is the computer that says the 4 injectors. Let me see. The 4 injectors only fire 4 injectors. So yeah, the blue channel that we have in our view. Let me remove all these readings in the zoom. So the blue channel is definitely firing injectors properly, but the red channel will not in the vehicle will not run the injector. So this is definitely that one. So the one we repaired already, this one here, it was the no start condition, and we have it already running. So it is definitely fixed. So we have one fix, and I'm sorry, but in this case, I have to repair the computers. And these are not inexpensive repairs. These are not inexpensive computers. And that's what I always try to tell the customer, look, new computer for this one, they're not really new. They're remanufactured. Some sellers might have it. They're upwards of $4,000. I use computer that you can find in eBay, and good luck with that, because sometimes it's hard to get your money back and everything. The $2,800, $3,000, $2,500 Mephi 4B. So yes, the repair is not going to be inexpensive in here either. So that's what I said. You know what? Don't open the computers. If you have a sunk boat and you want to open to see if it's full of water, I understand that, but please be careful closing it. Don't try to attempt to remove, because the gel was removing here, broken wires. Very hard to understand what you were trying to do there, Andy, and that could have deemed that computer completely unrepairable. Luckily for you, it's not the case. But yep, so I'm going to try to attempt the repairs on this one. I'm going to keep this one here, and we will run it probably again just quickly. Let me see if I can repair this computer, and I'll be right back. Let's see how long it's been going on this video, because I know I took the time to talk in the beginning. 32 minutes, not so bad. All right, I'll be right back, guys. All right, guys, I just spoke to Andy. So these are from different roads, as far as I understand, but they're actually a friend of his, and he called the person, and he said they're the exactly same engine, same setup, so that we can actually use either calibration. And the reason I'm saying that is because I have now the computer working properly as far as outputs and everything, but the faults are not able to get rid of it. So let me just show you. So let me move you over here so you can see that I have, well, the other computers, again, mark as number 2. And let me power up. All right, fuel pump and everything else was working the same way. So let me put the picoscope. Yeah, we have it. And then Diacom. All right, so let me connect to the computer. And let me just show you, make sure that you are seeing that. So let me make sure, okay, that is, yeah, you're seeing we had 3 full codes, and the calibration is 23B3. This is the computer that has 437 hours. It's going to go up to 470 or 469.9. The other one has right now, I forgot how many hours we have after the run. But that computer has absolutely no fault codes. Right now it's running good and everything is working fine. They're both 5.7. But yeah, these fault codes I cannot get rid of. I want to show you now the computer running. So I'm going to run it. Let me put the RPMs in the screen, and let's run it. Let me get it to normal range of RPMs, which is 650, as we were doing before the test. I don't like the way this simulator increases the RPM, because it kind of cuts the signals. But so yeah, right now what I did is I put channel A on the top and channel B on the bottom, with min, max, and low pulse width modulation. So we can see that both are almost a perfect image of each other. Both drivers are running good. Everything is, the computer is fully operational. Right now, if you connect this to the boat, it will be working great. But the problem with what we have right now is because of the fault codes, look what the buzzer is doing. It's going off and on and off and on. Give me 1 second, guys. Sorry about that. All right, so we can see the on and off of the buzzer. Yes, if you don't have the buzzer connected, you will not even notice it unless you connect the scanner. But what I talked to Eddie is I want to move the calibration from the good computer to see if that corrects the issue as far as the fault codes, because we can see that everything is working perfectly. Both signals are an image, so this should not be setting any fault codes about injectors. Why? Because they're both drivers and everything is now working properly. But when these got short or whatever damage, this computer could have corrupted a portion of the calibration, and now it's not seeing the injector firing even though it's firing. And that's what I want to see if I can correct with the order calibration, and I can do that in here, no problem. So let me do that and I'll be right back, okay? What I want you to, what I will show you, well, what I would do probably when I come back is I will run both computers so you can see it, but let me do a mark. So we can see that this is computer 2. So I'm going to put a mark in here. Yes, you're seeing it with the number 2. And this is going to be the only one with a number 2. All right. I like always to be very transparent. So I talk to my customers, I explain what is going on, and then we go from there. But yeah, so this is definitely a more intricate repair, even though, again, this computer right now is working properly. But we'll see how it goes. And I'll be right back. All right, guys, and Andy, good news. It's actually, yep, that took care of the fault code. So yeah, whatever took down the drivers on inside the computer on this computer, it also corrupted the maps. Not enough to create a checksum error, but enough to get those faults and not being able to erase. And look at, I mean, the proof is right now in the pudding, right? So let me see why is, maybe I have my oscilloscope up. Yep. All right, so we got now the scope running, and I'm going to put, well, let me select one by one as I did before. That is the new calibration on number 2 computer. So let me get you to here, and I'm going to get a closer look. Yeah, you can read in there. Perfect. So this is computer 1, and that is computer 2, which, remember what I did with computer 2? I put a mark on it, and that is on the other side of this one doesn't have the mark, but I'm going to connect this one because I don't want to leave anything hanging or nothing hanging. So everybody can see that this is indeed a full repair. So right now this computer is running perfectly. We have both injector drivers, a perfect mirror image of values, right? So injection millisecond, everything is good. So I'm going to put here trouble codes, 0 trouble codes. I'm going to put the engine hours, which is now 470.6, now whatever it was on this computer before, because it's obviously now the same calibration the other computer has. But I can go over to the trouble codes. We got nothing in here, so everything is working good. Trouble free is great. All right, I'm going to increase the RPM. Let me reselect the RPM. All right, you can see that in there. I'm going to increase the RPM to probably, again, 3,000, which is right there. I'm going to increase the throttle around 30 or something, and then increase the manifold pressure, as I did before. You will see the changes on the manifold immediately. I'm not sure why it's... no, we are getting an error on the blue one now. Let me double check my connections because it looks like we got a problem again. Let me stop the second and make sure my connections and the repair hasn't broken. All right, guys, it was actually the order injector driver. I didn't notice this until I went in inside. I'm like, that's actually the order driver, not the one I repair. So yeah, the order calibration was actually masquerading problems that it was actually more in there. So yeah, this was definitely or crapped out in after the repair of that side. But yeah, so and either way, I always repair both sides, but I want to address or stress to see if I have something else going on before I spend hours and hours on a computer that might be not repairable, right? But yeah, so now both are there. You can see both injector drivers, pretty much a perfect image. And right now I'm in that RPM. Let me actually put the RPM in your screen. For you, it's going to be like a second. For me, it's actually a couple of hours after. But yeah, I actually am going to go a little higher. Let me see if I can. Actually, that's the highest with this simulator that I can go. I will have to connect the other simulator, but realistically, it's not. It doesn't matter because this was exactly the sweet spot, right? So I'm going to bring it down to idle, and we can see both injector drivers now fully operational. I'm going to lower the throttle to between 6 to 10. It's a little hard to do that with these little knobs. And let me bring the manifold pressure to idle values, which is around 12.7, 12.8. So I got 12.9 in there, so that's pretty good. But right now, this one is working perfectly. Again, I want to show you the number 2 in there. No numbers in this other computer. All right, and that's the same with the number 2. So yeah, it is running good. Now we started on high idle and it went down to low idle. So I'm going to turn this one off because I want you, well, before I do that, I don't need to have it running to show you the rest so you can revisit with me. Again, no codes, calibration checksum, C4D4. And then right now on this one, 470.7 hours. After we run with no full codes no more, and both injectors at any RPM, both working properly, right? Which was a concern on this computer. It took me a lot of hours to repair this one. It's very meticulous repair. These are such a small areas and components in this already super small. This part, so you got an idea, it's like probably, I would say not even 3 inches by 3 inches. That's like literally, let me see, 1, 2, like 2.5, 2 3/4 inches by 2 3/4 inches. So think about it, you have a board inside there. All right, but let's just stop talking and let's do the other one. So I'm going to turn this off completely so I can transfer, let me disconnect from that one, transfer the computer or connect the other computer. So I'm going to keep this one. I'm going to put the cover in the back so we can, they have a position, so right here. Again, that's the one with the number 2. I'm going to keep it there. And we're going to put number 1 back in the test to make sure that everything is working good. Okay, so let's power it on. I'm not sure. I didn't see the... Yeah, everything is on. Let me make sure. Okay, let me check this one, guys. 1 second, because it's not connecting. All right, guys, I had to actually reload the calibration, so that was what I was creating the issue on this one. So, but now it is back in business. So let me move you over to this view. So we're on the same page, right? This is computer 2, which I'm going to reconnect just again because I want to keep everything without stopping the capture on one view. But let's just start with the one that was a no start condition. So we're going to reconnect or connect to this computer because we couldn't. So let me power it off completely. I'm going to power it back on, and we can see now the fuel pump coming on, and we're connected. So let me put the calibration. Sorry, no full code first. Calibration C4D4. Now these two computers are going to have the same calibration. And this one, since it has not run since I did it first, it has 470.6 hours. Remember, this one has 470.7. But yeah, so we have no codes. Everything is looking good. So let me put the RPM in your screen and run it. I'm going to raise it up to normal RPMs at idle. Just don't like the way this digital switches for this. I would rather have a nub. Hopefully this company, Jackie47, is watching my videos, because digital is no good for RPMs. You need to have a nub. All right, so we're in idle. We can see both injector drivers working good. I'm going to, again, max down the RPMs as we did with the other computers to make sure that we have no issues with this one. So we're in maximum 3100 RPMs. I'm going to increase the throttle the other way. I'm going to put it in like around 35 or so, and then do the manifold air pressure to around 20. And that's what we have now. You can see both injector drivers on 5.9. The computer is calling for 5.1, so we got the 0.8 on both computers now, but this computer is fully operational and running good. I'm going to move the red channel over to the EST signal for the coils, and we can see now that it's almost like a full bar because we're in 3000 RPM. So I'm going to lower the RPMs on this one to idle. 650. Let me wrap the throttle first, less than 10%. We're there, and then 12.7, 12.8, 12.7 that I use on the manifold air pressure for my tests. And we have everything nicely, everything is working good. All right, so I'm going to power this computer off. All right, so let me disconnect. Let me disconnect this computer with you guys in the video. All right, again, number 2 one more time. Or one last time, right? Hopefully. All right, let me power everything back on. We can see the fuel pump in there. Right, we got 5 volts and sensor ground. All is good. Let's run it, right? So we're going to start from the same thing, lower RPMs. I have to increase it. Now let me connect to the computer. Let's do it in order one more time. So again, 0 trouble codes, calibration C4D4, and this one has 470.7 hours, right? So 1/10 of an hour greater than the one we just were testing. All right, let me put the RPMs for you guys in there. Let me go over to idle. Oh, too much. I'm tired. These two are being funny. So we have one coil or one ESC driver for all the spark plugs. So this is a distributor vehicle, and then the injector on the blue channel. I'm going to move the red channel over to the injector so we can see both injectors. Remember, this was a computer with bad injectors, bad injector drivers. I'm going to raise it up again one last time since it's connected, right? So let me go over to the highest RPM I can go. Remember, that's it. We got both injector drivers. I'm going to increase the throttle one more time, around 35, 36. And do the same thing with the manifold air pressure. Everything is beautiful. No more glitches, no more problems. Everything is working good. All right, so let me bring it down to idle. 650. I can leave this right where I normally use it. All right, perfect. I'm going to show you that now this one computer is going to end up with 470.8 hours. And one last time, I want to just take it over to the next page where we were having fault codes that we could not get rid of with the auto calibration. Now we do with this one, and both computers are done. All right, Andy, thank you so much. This has been quite a few hours of work with both computers. But finally, we got everything working together and working fine. I will be contacting you shortly, collect payment, and send this your way. Thank you so much for trusting Myself Diagnostics. If you're here in the channel, please don't forget to subscribe. See you next time. Bye.